The method of selecting, modifying, and converting raw data into feature that can be used in supervised learning is known as feature engineering. In basic terms, it is the process of transforming raw assumption into desired feature through the use of statistical or machine learning approaches. It is a machine learning technique that uses data to generate new variables that do not exist in the training set. It has the potential to generate new features for both supervised and unsupervised learning with the goal of simplifying and accelerating data transformation while also improving the accuracy of the model. So if this makes you want to know more about it and you feel the need to dig deeper into it, sit tight as we bring to you all the information that you need right on your screens. If you haven't subscribed to our channel yet, I want to request you to hit the subscribe button and turn on the notification bell so that you don't miss out on any new update or video releases from Great Learning. If you enjoyed this video, show us some love and like this video. Knowledge increases by sharing, so make sure you share this video with your friends and colleagues. Make sure to comment on the video for any query or suggestions and I will respond to your comments.
We will be talking about impact of feature engineering on model performance. I really want to take this session in two parts. In the first part, I will give you a little brief about what exactly is a feature engineering. How do we differentiate feature engineering with feature selection? What are common methods of doing a feature engineering? So this is the first part, which I'll take you through the presentation, which should not take more than 10 to 12 minutes. After which I plan to dig on to the case study, wherein I will try to do some kind of an EDA as well, just letting you know why EDA is necessary before you get into a feature engineering. But please note that the EDA which I will cover when I'm going through the case study is not the complete EDA. There is lots which could be done, but the objective of showing you that part of an EDA is to let you know why it is important to study it. And then we will see how do we generate those features. Okay, so two parts, 12 minutes for a presentation, rest of the session through a case study. So let's begin. Okay, what exactly is feature engineering? Feature engineering is the process of using domain knowledge to extract features from raw data. Okay, this is the definition which I have picked up from Wikipedia. So the keyword here is a domain knowledge, which means whenever I get hold of any data, if I am comfortable with that domain, or if I'm aware about what the parameters they speak about or what the features they speak about, then it would be easier for me to extract the new features. Believe me, feature engineering is a difficult job as far as we as a data scientist is concerned, because it's not necessary that all of us are comfortable with all kind of domains. And when we try to gain the domain knowledge, there is every possible chance that we may have missed out extracting certain new features, right? So what is the process? Based on the domain understanding, the first and the foremost thing which we have to do is we have to decide which all features we need to create it. Then we create those features. Now, the third step is checking how the feature work for your model. In an ideal scenario, what is done is that we create one feature, look at the impact of that feature on the model performance. If the performance is really worked well, then we keep that feature before we create a second feature. Otherwise, we delete that feature and create a new one. However, just a caution here, if logically based on a domain understanding, if we feel that the feature which we created, although it is not showing a good performance, but when we create another feature which somehow is related to the one which was previously created, we may decide to keep both the features and look at a performance. Okay. So normally, theoretically speaking, we create one feature, we test the model performance on that feature. If the feature has not worked well, we drop that feature, we create another one. However, based on a domain understanding, we may decide to keep a couple of features together, look at a model performance, and we may decide to drop those couple of features which we have kept together based on how the features have worked on the model. So it's discarding the feature to test if created feature has reduced the model performance. This is a very, very, very important point to note. It is not necessary that if I have created a feature, it is always expected to either keep the performance same or increase the performance. When you will actually get hold of any practical data set, you will realize that if you have created some features which probably are not increasing the chances of the dependent variable prediction, then the model performance might just reduce, right? What is the idea of creating a features is that we are trying to extract the variance which is available in the independent variables so that the relationship between an independent variable and dependent variable is very high. For a good model performance, we want the independent variables to be highly collinear with the dependent variable. That's why we are able to capture the variance of the independent variables through the dependent variable. What exactly is the difference between feature engineering and feature selection? Feature engineering enables to build more complex models, right? It allows to build interpretable model from any amount of data. Why am I using the word interpretable? Because there are occasions and there are times when you have the variable available in the data set, especially in a BFSI segment. The moment we try creating some new variables which are probably related to the domain which we are talking about, then the model becomes more interpretable. I'll just take a very small example here. So let's assume if I have a data set which is a loan default, right? I'm sure you would have seen that data set multiple times. The variables which are available is when the loan was taken, when the EMI was paid out, when was the last EMI paid out, what was the amount of a loan, how many assets the individual has it, right? Now, for such kind of a data set, let's assume if I create a new feature, which I call it as a feature engineering, which is telling me loan to asset ratio, right? These ratio variables, which probably are talking more about the chances of somebody defaulting on a loan, or it's giving you more insight that how capable the individual is in paying out the loan, right? So based on a domain understanding, when we try to create those features, then the model become more interpretable, because let's assume in the same example, loan to asset ratio which I have it, if I know that loan to asset ratio is very high, it means the guy has been given a loan which is more than probably what we normally see in an average asset guy would be able to pay it. So we know the chances of somebody defaulting is very high. Okay. What exactly is a feature selection? What we try to do through a feature selection is the features which are significant, we try to extract out those features. So let's assume if I'm talking about a data set which has, let's say, 100 variables or 100 features available, we try to find out the ones which are significant, and through this, what we are doing is we are limiting the number of features. That's one. And second is we are able to so more the number of features which I have it, there is every chance that I might just do an overfit of the model, right? So I am reducing that risk also. There is a clear segregation between a feature engineering and feature selection, right? So let's be very clear in our mind. Feature engineering is that when I try to extract something new from the raw data. Feature selection is the given features which I have it, I am trying to reduce the number, I'm trying to reduce the complexity involved, I'm trying to minimize the overfit which might just happen because of the insignificant features which are available in the data set. Okay, now even a transformation like log or a scaling also changes the original form of the variable and features, right? Whenever we look at the data set, and let's assume if I'm talking about an algorithm, which are distance-based algorithm, and if I have a feature which has different weight than the other feature, then we say scaling is mandatory for those variables, right? Because we would not like the algorithm to treat a variable which has higher values as something which is more significant. So we scale it. Sometimes because the variable is skewed or the feature is skewed, and we do a log transformation of the feature so that the feature becomes normally distributed. Now, can we call these kind of a changes, or can we categorize this as a feature engineering? To my mind, not really. Okay. What we are doing is, although we are changing the form of the variable the way it was available, but we are not trying to extract something new from it, right? When we are scaling it, we are trying to manage the fact that it should not read that variable with as a highly significant. When we are doing a log, then we are normalizing it. So in my way, and this is just my interpretation, we do not call this as a feature engineering. Some of the suggestions, and please note that the suggestions which I'm sharing with you based on the type of a feature is a limited list. And it doesn't just end here, but this will probably give you an idea when you're looking at a data set that what kind of a feature engineering is possible. For a continuous variable, one of the most important thing which we try doing is a binning. Okay, we try to convert a continuous variable into a categorical variable by doing a binning. What criteria we look at doing a binning? We look at the various values which are available at quartile. So we create for our data set which is huge enough, and we might just decide to create 10 bins out of it. So we look at 10 percentile and then look at what are the values available and create a bin. Or for a continuous variable, we do a mathematical calculation like defining ratios. One of the example which I took was loan to asset ratio, performing mathematical operation on two or more than continuous features like an aggregation or a mean or a max, something like that, right? So we try doing a mathematical operation on the variable. For an object variable, we try to club two or more categorical object type of a variables, and we create a one. So a very simple example, let's assume if you have a data set, and the data set which I would be referring to has that one of the variable which could be created. So if I have a variable like an age, another variable which is or an age group kind of a thing which I have it, or I have another variable, let's say a marital status, and I have another variable which is a gender. So by clubbing the gender and a marital status, probably I can create another object type of variable. Encoding. Okay. Normally what we do is we use a label encoder. In this example or in the case study which I'll be referring to, I'll try doing an ordinal encoding. Okay. And when I reach there, I'll explain you what is an advantage of doing an ordinal encoding. We try to create a dummy variables also, right? Grouping based on one or multiple categorical variable. So the one kind of a grouping which I said was that when you club the two categorical variables, create a new one. The third is we try to do a clubbing of the levels. So if we look at that the distribution of various levels available in a categorical variable is not uniform. Let's assume a categorical variable is a product category type, and it has, let's say, 50 categories which are available, and I know there are only 4 categories which contributes to 80% of the data set. Then based on the domain understanding, I might try creating a new variable by clubbing those levels which is available. Okay, I can perform a mathematical operation on this, which is a count or a max or a min value. Date variable. This is a very, very, very important variable which is available in the data set, because a lot of factors which you can study on the data set based on this date variable. You can extract out a year, you can extract a quarter, month, day of the week, weekend, season. So date variable is, especially when you will see the data which is related to a retail shop, or if you're looking at a weather forecasting kind of a data, the date variable carries a lot of importance, and these are some new features which you can create. Text variable, wherein if you have a text kind of a field, we try to segregate the text and probably take out the text and the numbers which are available. So sometimes you will come across a data set which says the duration is 1 year, 5 months, right? So this becomes a text kind of a field because it has a number which is available and a value. So what we try to do is we try to extract out one from a year and a month and then convert the entire field into a month. So this is one of the example which you can do for a text variable. Then what is feasible is any combination which I just now said it, right? So that's why we say feature engineering is an iterative process. And the story doesn't end here because feature engineering is an art which requires a domain knowledge. Okay, so it will never be the scenario that I would be able to confidently say that whatever features could have been extracted has been extracted. That may be based on my domain understanding. And this feature engineering is one of the important aspects which really differentiates your model from somebody else's. One caution to note. It's not necessary that more is merrier in case of a feature engineering. Why? Because we should not fall in the curse of dimensionality. It should not happen that I really create number of features which are more than number of rows, and hence my model performance really goes for a toss. Okay, when I'm taking you through a case study, I will give you an example of a feature which could be created like that, and I'll tell you why I have not created that feature. So with that, let's move on to a case study. So what is the problem statement? A Private Limited has retail stores across the globe. They are struggling to generate revenue through their high-end product sale. The company has hired you as a data scientist to help them to design personalized offers for their customers based on their purchase behavior. Okay. A Private Limited has collected demographic details of their customers like age, gender, marital status, and city, along with the total purchase amount in a month to understand the purchase behavior of high volume products. Now, what exactly is the data set? This is how the data set looks like, right? So what you have is, you have a customer ID, you have a product ID, sex, age group, job, code, city, living in that city since when, married, which is a binary categorical variable, values are 0 and 1, product category 1, 2, 3, these are 3 different product categories you have it, total purchase amount. Okay, so the objective of the data set is that we would like to do a prediction to find out that how much has been a purchase from a customer, because the objective is that we would like to help the organization to increase their revenue. Now, when I'm looking at a customer ID, because this is a transaction data, what I normally see is I have a lot of records, a lot of rows pertaining to a single customer, which I have it, right? When I actually go on to the product ID, then these are different products which an individual has purchased, which is expected because this is a transaction data of a month which I have it. Normally, whenever we have such kind of a data set, what we say is customer ID is useful to find out if there are any duplicate records available or not. If not, then when I start working on the data set, the first thing which I do I remove the customer ID, right? Now, for such kind of a data set, it will be difficult even to find a duplicate records also. Why? Because there is every possibility that when I went to a store on a particular day, I did a purchase of a category 12 and I decided to do a purchase of that category 12 again one more time, right? Which is highly possible. So it is very difficult for me to find out a duplicate records here in this kind of a data set. Wherever you see a null values, it's not necessary that mode will always work for you. Okay, I'll explain it to you what kind of a way you can do for an imputation. And you cannot assume that the null value which is available is definitely the reason the product category, or you do not have any product category 2 available for that, right? Unless there is any information given it to us, we will assume that this is a real null value and requires an imputation. Fair enough? So this is what the data set is. Age group has, because it is a group variable, it is a categorical variable. Before I move on to the Python notebook, one last point to note here. What it looks like to me is that I have everything which is available as a categorical variable, and I am doing a prediction of a numeric variable. Correct? So, and this is the typical data set which we have chosen, and I'll just explain it to you. How do you handle that? Because normally speaking, if you have, or if you are predicting a numeric variable, most of the time you would have seen that you have some of the variable which is giving you a numeric information. However, if you look at whether the product ID or a sex or age group or whatever, all the variables are categorical type. Let's move ahead. So these are the standard libraries. I'm importing the data, right? Standard details, guys, I will not talk about in detail because the assumption is all of you are aware about which are the libraries which I'm talking about. So NumPy, Matplotlib, Pandas, Seaborn. So this is the file which I've imported. Okay. Now, when I look at it, I have 537,577 rows and 12 columns, 12 features. This is how the file looks like. When I go on to the info, what I see here, I have a customer ID, which is an integer type. Product ID is an object type because I have the product ID with AA because it's an AA private limited data. So it's AA as a product ID. Sex, age group is an object type. Job code appears as an integer type. City object, married is appearing as an integer type. These category 1, 2, 3 are integer type float. And total purchase amount is appearing as a float type. Now, what do you see here? Product category 2 and 3 have a lot of null values available. Another point to note here, out of 53,7,577, if I have only 1,64,278 records available, that means I have almost 70% of the missing value, right? Normally, when we are making a model, what we say is if you have a data set which has so many missing values available, it doesn't make a lot of sense to impute it because then you are actually synthesizing the data, right? Herein, I'll tell you a method for doing an imputation. So I'm practically not deleting anything. I am checking for a duplicate, right? As I said it, that there is almost impossible to find anything which is a duplicate available. When I go through a normal routine of finding out if there is any duplicate or not, I do not get any duplicates available. Now, how many unique customers and products which I'm talking about in a month? So I'm talking about 5891 customers, and I'm talking about 3623 unique products, right? Unique value for each categorical. So in the product ID, I have 3623. I have shown you earlier. Sex has 2. Age group has 7. City has 3. Living in the current city since has 5 levels available. Okay. Now, before I get into creating any of the feature, it is very important for me to understand what is the data set telling me, right? So that's why it is important that we get into an exploratory data analysis. It's important that we try to extract out or get insights from the data. As I said it in the beginning of this session, the EDA part which I'm doing here is only to get some insight from the data or just get familiarized myself on the data set, right? This is not a complete EDA by any chance. So the first thing which comes to my mind is that the retail business heavily depends on what kind of a customer comes in. So let me see what is the distribution of the age group according to a gender. Okay. So what I see here, this retail business have a lot of customers which have come in the last 1 month, right? Everything which I'm generalizing is based on the last 1 month data which I have it. So a lot of customers which have walked in are from 26 to 35 age group. This is showing me a distribution of female and male. Now, any category which I look at it, I have more male than a female, right? So maybe this retail store caters to more products which are pertaining to the male as a gender than a female. I'm not sure. I don't know because from a confidentiality purpose, most of the practical data set which you will get it will never show you what this product name is, right? That's why you are given an ID even for our categories as well. But when I start looking at the data set, probably it looks like that the retail store has more products which are pertaining to male and it has more products which are pertaining to 26 to 35. Irrespective of the gender, even for a female, I see a the highest bar for 26 to 35. Okay. Then the second question which comes in is, okay, so more number of males, but is the average purchase amount is also higher for a males? Maybe in terms of a count of a transaction, I have more number of males, but are the male customers generating more revenue as well for the business or not? So what I've done is I've just taken a mean of the purchase amount based on a gender. Okay, so what do I see here? 12673 is an average value, and 11746 is an average value for a female. So yes, male count or number of transactions pertaining to male as a gender is high, and even the average purchase for a male is also high. Does average purchase amount differ across groups, right? So after this, the first conclusion which I had was that 26 to 35, I have lot many records available. Now, I need to find out, is the average purchase amount is also high? Why am I doing so much of analysis on that? Because I really want to find out, are these variables, age and the sex, are these variables giving me some information so that I can generate some new variables from there, right? So when I am looking at a age group wise total purchase amount as a mean, so what do I see here? Yes, there is a variation which is available. When I'm looking at the 26 to 35 age group, it is 12419. It is on the high values, but it is not the highest. Okay, it is not the highest. Look at something which is 51 to 55. I have an average which is 12827 or 36 to 45. If you look at it, this is higher than 26 to 35, right? So it is telling me that maybe there was, because let's go back one more time onto the data set problem statement. My apologies. High volume product. Okay. So maybe this age group has purchased, may have not generated a high number of a transaction. If I just go back again, 51 to 55, I do not have a lot of transactions if I do a sum total of male and female. But yes, the average amount has been high because maybe the organization was looking at a high-end product in terms of a volume, in terms of a revenue. So in terms of a volume, maybe 26 to 35 is giving them more number of transactions. But in terms of a average revenue, 51 to 55 probably is giving you more number of transactions. So what is the, what am I trying to gather? As I move along, I'm able to see there is some kind of a relationship which I have it when I am looking at a purchase amount with respect to age and whether the guy is married or not, right? Does purchase amount is different across a different job code which I have it? So these are the job codes which I have it. When I go down, yes, I'm able to see that there is a difference which is available. And for a job code which is 15, then this clearly shows me that this is on a higher side. The same goes with a job code as 12, right? So what the further analysis which I should be doing it is, I should be looking at for a job code, for a age group and a gender, right? I have not done that as an analysis, but I'm just telling you that this is how the story builds in. Then I'm looking at, is the average purchase amount is different for married customers, right? When I go ahead and look at it, then somebody who is married is high. Okay. Can I club the earlier observations? 26 to 35, lot many transactions. Probably this is the age when we assume that somebody is either married or will get married. Then that there are a lot many transactions are available, but there are people who probably are not married and the married have generated a high transaction. So maybe I can go and suggest the business that target 26 to 35 who are not married, and maybe you can just push them for certain different products. Then I am looking at what is the product preference based on a gender, and I've done it for a product category 1. Now, which are the products which are being preferred? This is for a female and this is for a male, right? So there are 3 bars, and just look at the colors, right? These 3 bars are showing you the highest one, irrespective of a gender, which means these are the products which are generating you many transactions. So these are definitely a high volume product category. Okay. Now, when I look at for all the different category group, which is not just one, I looked at 2 and 3. Why I did this segregation only for a product category 1? Because 2 and 3 had a lot of null values. So I thought of looking at them a little differently. So when I look at total number of records which I have across the different product groups, then I'm able to see for this category 1, these are the ones, category 2 and category 3, right? For further analysis, I can club these categories along with the product ID. But before I do that, I would really like to see that the null values which are available, how can I do an imputation of those null values? So as a pre-processing, what I did was, I looked at the product category distribution against an age group. Okay. This is one way of doing an imputation. One simple way of doing an imputation could have been, I could have just looked at the mode of product category 2, and I could have looked at mode of product category 3, and I could have done an imputation. Why I was not very comfortable in doing that as an imputation was because product category 3 had many null values. So I really wanted to see is how has been the distribution of these categories across the age group. Now, when I look at it, then for a category 2, this is the category value which I have it for 0 to 17. For all other categories, the value which I get it is 8 for category 2. Look at category 3. Most of the values are 16. Okay. So there are two ways of doing an imputation. A little computer heavy or little computational heavy imputation is, I look at each product category 2 and then do an imputation based on the age group which I get it. Okay, I hope everybody is getting me that. Which means I look at a record, whether that record belongs to 0 to 17 and is null, then I do an imputation based on a 4. But as most of the values were 8, I took a simple, just from a computational purpose, I took a simple imputation by doing an imputation as 16 and doing an imputation as 8. So what I have done is, I have looked at what is the product category available for a age group. Okay, across a age group, what is the product category I have it? So 0 to 17, which if I look at it, then I have the category available as 4. 18 to 25 category is 8.0. So these are the categories which I have. Now, once I have figured out based on the age group, why did I select age group? You could have done it a little differently also. You could have probably selected the value or the most occurring value based on, let's say, a job code, right? The reason why I did it based on an age group and not based on a job code, because there were a lot of job codes which are available, like 20 is a job code, right? I did not wanted to look at the grouping of the 2 and 3 category based on a variable which is 2 less. Like, let's assume if I have selected something like a married, which is 0 and 1, right? So then it will just tell me 2 different values. And I did not wanted to select something which is too many categories which are available, like a job code, because there are 20 categories. So as a middle ground, I selected a age group. Yeah, okay. Let's assume if there is a variable 1 and it is a variable 2 and it is a variable 3, and let's assume it goes till variable 25. Okay. And you have a missing value available in variable 3, and you have a dependent variable as dep1. Sorry, let me just call it as dep. So you have a data set which has independent variables from variable 1 to variable 25. Dependent variable is dep, and you have missing values in variable 3 and 5. What mice internally does it will divide this data set into 2 parts. One, it calls it as a train, the another one it calls as a test. The first time when you are doing an imputation of variable 3, train will only have all the records which have value for 3, which have value for variable 3. Okay, and test will have all the records where var3 is none. Okay, then what it will do is it will consider variable 3 as a dependent variable and build a regression model. I am making a model using a trained data set for doing an imputation of variable 3. Okay, so trained data set has all the values available for variable 3. Variable 3 is a dependent variable now. So how will the regression equation look like? Variable 3 is regressed on all the variables, including dependent. Okay, so I have made a model. Now I will use this model to do a prediction on the test. So what will happen? When I use this model to do a prediction on the test, I have got the values for variable 3, right? Making sense? So now I have got the data set which is full. The first step of a feature engineering which I am doing here is I am doing an encoding of the features. Okay, there are two parts which I'll show you. One is I will do an encoding, and second is I will create some new features. Now, encoding, normally what happens is if I use a label encoder, then based on which one comes first is the label which is given. Based on what you really want the algorithm to look at it, we can use an ordinal encoding. What is an advantage of an ordinal encoding? If I want, so let's assume if there are education groups which are available, right? Now, if somebody is only a 10th pass, then I have a group which is 12th pass, then I have a graduate. When I do an encoding, what am I assigning? I am assigning a numeric value to it. I'm assigning a value as 1, 2, and 3, right? When I assign a numeric value and when I run an algorithm actually treats them as an integer value, where 1 is less than a 2 and 2 is less than a 3, right? If I want the levels to be attached with the numbers, then rather than blindly using a label encoding, I do a ordinal encoding. Okay. And another example, if I have a sex, right? If I have a male and a female which is available, then I will not use an ordinal encoding because I do not want, if this is 0 or this is 1, then I do not want any kind of a level to be attached to it, right? But if there are variables which are categorical and I want the integer conversion which happens, I really want the level to be attached to it, then I do use an ordinal encoding. Herein, because when I did an EDA, 26 to 35 age group was showing me a difference and 50 to 55 was showing me an average value which was higher, I decided to use an ordinal encoding for an age group. Now, so we have done a ordinal encoding for an age group. We can convert a binary sex variable by using either a label encoder or like this. I have used a dictionary for converting Delhi, Chennai, and Mumbai. I could have done through a label encoder. It will exactly do it in the same way because it is, it will do it in a little different way because Chennai is considered as 0, Delhi as 1, and Mumbai as 2. Why I have done Delhi, Chennai, and Mumbai 0, 1, 2? Because when I looked at the unique levels distribution available in the data set, what I had was Delhi was showing me the least, Chennai was second, and Mumbai was third. Okay. So that is why I have not used a standard label encoding and I have given 0, 1, and 2 here. Fair enough? Okay.
Yes.
Now, customer ID and product ID. As I told you in the beginning, normally what happens is we do not want any customer ID or a product ID to be considered. Customer ID to be considered in a model whenever we start building a model because we feel customer ID probably would not be a case. Herein, when I'm creating a lot of new variables, I would be using customer ID and product ID. And just allow me 2 minutes, I'll just show you that. How do I do it? Before I get into a case wherein I start doing a feature engineering as step 2, which means when I'm done with the label encoding, I will do a label encoding for a customer ID and product ID as well. Because as I said, I intend to use these two variables to doing the feature engineering in terms of creating a new variable. So I have done a label encoding for customer ID and product ID as well. Okay. Now I have intentionally kept sex here because I said either you use a label encoding or you create it that way I showed it to you, it will give you the same result. Now, once I have done it, I have created a dummies for living in current city state ones. Now, what am I trying to show here? I'm trying to show you multiple ways of dealing with the categorical variable in terms of either using an ordinal label encoding or a dummy creation. What will a dummy creation do is it will allow you to create a binary for each level, right? I have said drop first. I'm sure all of you must be aware about it. Drop first, otherwise it will result into a multicollinearity scenario. So this is what the data set looks like once I have done it. So I become customer ID and product ID have become an object type. Living in current city is the UINT because this is a dummy which I have created. Now, the first step of a feature engineering after an encoding, I've done it. I tried creating a decision tree model. Split and all, I'm sure all of you know it. Why I tried creating a decision tree, not a linear regressor, and I would encourage all of you to create a linear regression also, and if required, use a regularization technique like ridge and all. The reason why I thought of creating a decision tree was because, as I said in the beginning, I have all the independent variables as a categorical variable. So my intention was that if it is a categorical variable, categorizing that, finding out the most significant variables would work best if I am using a decision tree. So that's the reason I thought of using a decision tree. When I looked at an RMSE and the R2, I got an RMSE as 5040 and an R2 as 42. When I looked at the important variables, product category 1 has come out to be the most important variable. Okay. Now with product category 1 as the most important variable and customer ID and product ID also coming out to be important variables, this has given me a hint of saying I should create some more features. I should try extracting features from these variables. Okay. Just from a comparison perspective, after a decision tree, I created another model as a gradient boosting. Why I created that? Because before I end this session, I really wanted to show you that even after doing a hyperparameter tuning, if you use a data set which has features which you have created, it will give you a better performance. Okay. So we will not get into a detail of why I selected 100 and all, but these are the parameters which I will be keeping the same when I get into a feature engineering also. Okay. So I created a boosting, I used a boosting algorithm. Boosting gave me a performance as 68 and RMSE as 3742. Now, what I have tried doing is, I have done the step 2 of a feature engineering, wherein I'm trying to create new variables. Now, the first variable which I've done it is, based on a customer ID and a total purchase amount, I have created a mean value. Okay. Why am I doing that? Just imagine. So what will this syntax do? It will, by doing a grouping of customer ID and the total purchase amount, right? I am taking a mean, which means, and I'm creating another column which will have a mean value available for a customer ID, right? Why I decided to create a mean? Because when I looked at the EDA, I was able to see a difference which is coming across the mean value, right? For different categorical variables. So that was the reason I thought of doing a mean. Similarly, by using a product ID, I have calculated a mean. Okay. Now, what I'm showing you here is I have already done a split of a data set X and into a train and a Y. So what I'm doing here is I am creating a variable and using this transformation for imputation or for creation of a new value for a test. It's very similar to the way you do a scaling, right? You do a scaling using a trained data set and then you fit it onto the test data set. The same logic I have used here for creating a mean variable by using a customer ID and a product ID. Now, when I create a new model by using these two new mean variables which I have created, what do I see? Customer ID mean price and a product ID mean price, they become significant. And remember, product category 1 was the most significant variable in the base model. And when I have created a mean price value, then what do I see here? These two variables have become significant and this is not that significant. Okay, this is model 2 which I created. Let's go back and look at my RMSE is 4763, my R2 is 0.483. So which means I see a jump from 42 to 48 in an R2 and I do see a decrease in an RMSE value from 5040 to 4763. Okay. One important point to note here. Whenever you are creating a new features, right? So till now we have just created 2 new features in terms of a real new features after encoding it. Okay. What I have not done here is without doing encoding the way we done it, you should try creating a model when you get hold of this notebook. You should try creating a model by using a label encoding and you will see that the model performance probably would be little lower than what I've shown you as 0.42. Okay. So we created a model by using a label encoding and the ordinal encoding. Then we created by using 2 new features. The performance is improved a little, which is 0.48. Point which I was making here is whenever you do a feature engineering, there are not too many occasions, right? When you will see a grade jump. When I say a grade jump means from 0.42, you have really moved to, let's say, 75, 79, something like that. You will not see a great jump in most of the cases. Why? Because when we are trying to extract new features, we are just trying to capture those variance which is available in the independent variable into the new feature. It will never, most of the cases, I should not use the word never. In most of the cases, this scenario would not be that you will see a huge jump. In fact, if you see a huge jump, then you should go back and look at the data set. There is a high probability that probably the column which is showing you that huge jump is not properly clean. Then using the same logic, because the mean price was giving me a good value in terms of increase in an RMSE, increase in R2 and decrease in RMSE, I thought of creating some more features by not just using a mean. I thought of doing a max and a min max. Okay. Then I could have created a model for this, but I thought it will become a little too heavy from a model perspective to look at it. The 485 is the new R2 which I got it, and this was 4839, right? So with the 2 additional variables, max and min, using the same logic, has shown me a marginal improvement in an R2. Okay. Then what I thought was, let me just go back and shift to the product category 1. Because product category 1 was the most significant variable which was coming out for the data set. 1334, just one second. So then I thought of creating using a product category 1. So product category 1, I created a max, min and a mean. Another kind of a variable which we normally do is a count variable whenever you have a categorical, right? Remember I showed you in the presentation. So I did a count group by a customer ID, all the categorical variables, product ID, age group, job code, product category 2, 3 and 1. Okay. So then with these new features which I created, when I looked at it, the customer ID mean price and the customer ID mean price still continues to be the highest, but some of the count variables which you see here have become more significant, right? So now this after creation of these variables, the one which I got was a 4.9, again a little more jump, RMSE a further reduction, which is 4.722. Now, when I tested the model using a gradient boosting with the same set of parameters, what I got was remember with the gradient boosting, the first model which he created was 68. This has given me 73. Okay. Two questions which I'll answer it now. One, if you just limit to a hyperparameter tuning and if you do not try to get into a feature engineering, and I'm sure all of you are aware about it, there is a heavy chance of you overfitting them. Okay. So it's not that you should just keep tuning it. So I might just change it to 100 to 200 or might just increase the depth. There is a very high chance of doing you getting into an overfitting. Now, why did I stop here? There could have been more features which I created. Answer is yes. Some of the more features which I would like all of you to look at it when you get hold of this book. Age 30 to 26 to 35 is the most significant age group in the data set in terms of account. Also, average purchase amount is different for married customers. Can these two features be combined together? Dummies from product category 1, as this was the most significant feature in the original data, right? I never created a dummy from product category 1. Convert the new feature created after grouping based on customer ID and total purchase amount into a categorical variable, right? The mean or the max value which you got it, can I further club them? Can I look at a quartile value and then probably decide it further, right? There are possibilities. And there are other features also could be created. But what we should also look at is when we get into a feature engineering is the curse of dimensionality. One of the feature which came to my mind and I did not create it and I wanted to share that with you is, if I create a dummy for each product, which is like whether the guy has purchased the product or not. So what I'm saying is, like the way we do it in a market basket analysis, I create a transactional table, which means I have product ID, each product ID, I have a column available. And I create a transactional table wherein I say whether this customer has purchased this product or not. I could do that also. What will happen? What will happen, guys, if I do that? If I create a dummy for each product category, but I'm sharing it with you so that you know what happens. So I just thought of selecting the 100 ones. I just thought of selecting the 100 most selling products in 18 categories, just that. And when I did it, it has created a data set file, which is 551 MB plus. Okay. So whenever you are getting into a feature engineering, please be sure that you do not get into a curse of dimensionality, because if I would have done this, first of all, I really don't know unless I use a collab whether the model will work or not. I am really not sure about it. But if I have used this, and what will happen is there is every chance that the number of features would become more than the number of rows, and I do not get a model which will make sense.
If you haven't subscribed to our channel yet, I want to request you to hit the subscribe button and turn on the notification bell so that you don't miss out on any new update or video releases from Great Learning. If you enjoyed this video, show us some love and like this video. Knowledge increases by sharing, so make sure you share this video with your friends and colleagues. Make sure to comment on the video for any query or suggestions, and I will respond to your comments.